car starts moving from rest and accelerates uniformly at 1.2 meters per second squared for 20 seconds, after which it decelerates uniformly at 0.3 meters per second squared for 16 seconds to attain a constant velocity. It then moves with that velocity for 36 seconds, after which the brakes are applied and the car uniformly decelerates to rest in 8 seconds. Draw a velocity time graph to illustrate this motion. Calculate the total distance traveled by the car. Calculate the average speed of the car. So this is also a question on velocity time graph. So the first thing to do is let's try to have a general idea of how this velocity time graph will look like. How it will look like. So if we have the velocity in meters per second on the y-axis, we will have time in seconds on the x-axis. So a car starts moving from rest. This tells us that it has to start from the origin. So initial velocity has to be 0 meters per second. And then it accelerates uniformly at 1.2 meters per second squared. So the car starts from rest, then accelerates at what? 1.2 meters per second squared. This is acceleration, and you should never take it as the final velocity. All right? But what was the duration of the acceleration? 20 seconds. So from here to this point, the duration was 20 seconds. Then what happens after that? After which it decelerates uniformly at 0.3 meters per second squared for 16 seconds to attain a constant velocity. So which means from this point, the car then decelerates uniformly at 0.3 meters per second squared. This is also a deceleration, okay? A deceleration is a negative acceleration. Acceleration will increase the speed of an object, but deceleration will decrease. So that is why from here we have to bring it down. So which means this is the deceleration from this point to this point, okay? And what was the period for deceleration? 16 seconds, okay? It lasted 16 seconds. So what did the car do after that? It moves with a constant velocity, okay? It then moves with that velocity for 36 seconds. So after it decelerates to attain a final speed here, it maintains that speed, okay? So that was a steady or a constant speed. And that lasted for what? For 36 seconds. For 36 seconds, all right? Then afterwards, what happened? The car uniformly decelerates to rest for what was the period? The brakes are applied and the car uniformly decelerates to rest in 8 seconds. So which means the car decelerated in 8 seconds. So this is how the velocity time graph is going to look like. It's not drawn to scale. Roughly this is it. So what do we understand? Just to summarize overall, the car starts from rest, accelerates uniformly at 1.2 meters per second squared to attain a velocity, okay? So that was a higher velocity. Let's call it V1, okay? Because that's the first instance. Then from here, the car decelerates uniformly to attain, because deceleration will make it to attain a lower speed. And we can call that V2, all right? We can call that V2. So from here, the car decelerates to attain a lower speed, but after attaining that lower speed, it maintains that speed for 36 seconds and then decelerates to rest. So this is how the velocity time graph is going to look like. So which means we have like 4 events, 1, 2, 3, 4 during this motion, okay? So what can we do? We have drawn a velocity time graph, so but we have not yet known the time, the final velocities attained. So for the first instant, when the car moves from here to this point, we can find V, okay, V1. So let's say if we have V equals to U plus 80, but since we have different speed, let's try to specify. So the first velocity is equal to the first initial velocity, the first acceleration, the first time. So we can just say v1 u1 equals to a1 multiplied by t1. So what is the first velocity? It starts from 0. So it's going to be 0 plus what is the acceleration, 1.2, and what is the time during the acceleration is 20 seconds. So what will that give us? That gives us a velocity of 24 meters per second. So v1 is equals to 24 meters per second. Or if I just want, let me just indicate it directly. All right, 24 meters per second. Okay, so I need to find v2. So the v2, what you have to understand is the final, for a velocity time graph, the final velocity of the first event will serve as the initial velocity for the second event. So if I told v is equals to u plus at, again for the second event, that is this portion, when the car was decelerating, we can say v2. So it will be v2 is equals to u2 plus a2 t2 the second time. What you have to understand here, this u2, that is the initial velocity for the second event, will be actually the final velocity of the first event. So which means what will be the u2? 22, because 24, sorry, this is where it starts to decelerate from 24. All right, so it will be 24 plus, but what is the acceleration? Again, it has to be minus because it's a deceleration, so it will be minus 0.3, and what was the time taken for that is 16 seconds. So calculating that will give me it will give me 19.2 meters per second. All right, it will give me 19.2 meters per second. All right, so this v2 can be represented as 19.2 meters per second. All right, so what can we do? It asks us to find the total distance. So if you look at this, it gives us different shape. We can just go and use the separation method. So let's call this one distance 1, distance 2, distance 3, and distance 4. So for this first event, this is how it looks like. It's a triangle with the base 20 and the height is 24. So S1. So if at all I want to find the area for S1, area is equals to half base height, and that will be half. The base is 20, height is 24. What will that give me? That will give me 240 meters. 240 meters. All right. So let me just delete this. All right. Okay, so for S2, let me try to sketch how it looks like. This is how it looks like, S2. All right, so this point from here to here is what? From here to here, it is 24. All right, this point from here to here is what? Is 19.2, and this point from here to here is 16. So this looks like a trapezium. And so what is the area of a trapezium? Area of a trapezium is equals to half a plus bh. All right, half a plus bh. So that will be, should I move here? Half, what is the a? Is this length? 19.2 plus 24 multiplied by the height is 16. And what do we get from that? we get 345.6 meters. All right, that is S2. So if I move on to calculate S3, what is the shape of S3? Is an area of what? Of a rectangle. An area of a rectangle is the length times, let's say, the height. So what if we take this as the length is 36, and what is the height from here to here is 19.2. So 36 times 19.2, what do we get? 691.2 meters. All right, so we move to S4. S4 is a triangle. Area of a triangle is half the base times the height. What is the base? The base is 8, and what will be the height? 19.2. So what will that give you? You have 76.8. Okay, so we are able to find the individual distances. So what we will head on to find is the total distance. So distance total is equals to S1, S2, S3 plus S4. What is S1? Is 345.6. What is, sorry, S1 is 240. Let's correct that immediately. 240. What is S2? S2 is what is 345.6. What is X3? 691.2. And what is S4? S4 is 78.6. Getting that total, what do we have? We have here 1,353.6 meters. Okay, so that's the total distance. The final question is the average speed. The average speed is the total distance divided by the total time. And what is the total distance? 1353.6. And the total time, if you calculate everything, you're going to have 80 seconds. So if you divide, you're going to have 16.92 meters per second. That is the answer.